All right, we'll go ahead and get started just to make sure everyone is in the right spot. This is MCL 1439, an end-to-end demo of taming public clouds with CloudHealth and vRealize. So we're going to be talking about how the vRealize suite of products and CloudHealth can come together to monitor and troubleshoot and automate our public cloud deployments. So I'll go ahead and get started. Let's jump into it and get started with everything here. Just before I jump into anything, want to make sure everyone sticks around till the end here. I'll be showing a QR code so we can get some VMware Cloud Management gear at the end. So there'll be a QR code you can scan and get some swag. So we are going to talk about our public clouds today and how we can, again, automate, monitor, troubleshoot those public cloud deployments. And the way we're going to do that is by using a fictional company here that we've created, which is MOAD, or Massachusetts Omni Automated Devices, a firm that was founded quite a few years ago. The bread and butter so far has been large industrial robots for use in self-driving farm equipment for automotive industry, for AI research projects. And most recently, they've added into their capabilities some online sales. They're selling some robotic kits online. And it's really taken off in a number of regions across the globe, specifically the United States, in the United Kingdom, in Russia, in China. And so this is something that they need to kind of work on a little bit, since all of their deployments or everything is right now is kind of in a private cloud. And they want to work on getting more to more of a public cloud focus. They want to be able to expand into these new regions. Really kind of decided that they needed to get this multi-cloud footprint up and running rather than just running solely on their private cloud. And so they've decided to leverage Amazon Web Services, leverage AWS in order to be able to expand globally, get these robotic kits selling out to the world with applications that are run then on in multiple geographic regions. In order to do this, they've decided to utilize the VMware Cloud operating model. And really, this is what all of this is starting from the bottom and working our way up. We want to be able to take data from anywhere that we have that, whether that be private clouds, hybrid clouds, or any of the public clouds, and take across any of our deployment methods, whether that be virtual machines, containers, the native public cloud services, or Kubernetes, and really then use the three pillars we've decided to focus on. The first one being acceleration and speed, really trying to take anything out of the way that might be slowing our developers down. Our cloud operations optimization, so we're trying to really make sure we have the right number of resources assigned to our services, not too much that we're overpaying, not too little that our performance is struggling, and also our cloud governance. So really trying to make sure we have everything that's out there, regardless of cloud, so we can manage and optimize our costs, our capacities, make sure that they're safe and secure as we move forward in the whichever cloud we're speaking about. I want to introduce our team real quick. Obviously, we're going to be looking at this challenge from a number of different personas. So the first is our network architect. Network is obviously we're looking to make sure that our applications have the bandwidth they need across the network to make sure that they are happy and performing well. Our platform engineer that is worried about scalability and performance, make sure our applications can scale and perform as needed. Our cloud architect, who is making sure that our applications have the resources they need from the public cloud and they can consume those as they move along. Our app developer, who is deploying across multiple clouds, multiple regions, as we talked about, and make sure we have availability as we go forward. And our security manager, who is then defining our security policies and making sure that no matter what cloud we're talking about, our business is protected, and these applications can run no matter where they are. So there are a couple questions that MOED has decided to kind of ask themselves as we move into the public cloud here. The first set is around self-service. So how do we get the automation we need in order to have these applications running, and the app developers can have the information or the deployments as they see fit. We want to make sure we're managing our public cloud costs, our usage and capacity. We want to make sure that those are secure and compliant across the public cloud as well. And then how can we manage these applications? How do we monitor? How do we troubleshoot if any challenges arise? And can we get any sort of logs from our public clouds, and how can we use those going forward as well? The first set of questions will be looking into a little bit of automation and what our options look like for self-service and our day 2 self-service actions as well. So Francisco will actually be taking this part. So Francisco, I'll let you take it away from here.
Thank you, Tim. Let me start sharing my screen now. Go. All right. So yeah, let's get started. So you got a public cloud now. You want to enable your developers, your consumers, your customers to self-service themselves to access this new cloud environment, to deploy new workloads, and more importantly, enable them to perform second-day operations during the whole lifecycle management of these workloads. So how can you do that? Especially make the same experience transparent regardless on which cloud you are operating, on your private or public cloud. So how can you do that? With vRealize, it's essentially a couple of steps that you need to perform in high level. The first one should be the configuration of the system, the configuration of vRealize to make it enable and be able to use this new cloud environment. And the second part would be to enhance your existing infrastructure as code definition, your cloud templates, to take advantage of this new cloud environment and make it transparent to your end users. So right now, as it stands, you can tell that my developer, my customer, can request the Mo application, and they can do it in the existing environment. There is just one version at the moment for this kind of workload, but it is limited to the VCF environment, my private cloud, right? So we want to extend this. So the first step, as I mentioned before, is to make sure that vRealize is able to access this new public cloud environment, and more importantly, that you can organize the resources in a way that can be consumed in a controlled way, right? You probably don't want to give access to the whole public cloud. You may want to allocate resources in a specific to any given project, and be able that you can govern how those resources are going to be used. And in order to do that, you need to add a new cloud account for this new environment. You can see here, it's very straightforward. You just need to hook up vRealize to that cloud environment. You just need to do it once. And once you have access to the cloud resources, you can start organizing these resources. And you do it by starting with the cloud zones. And just so you understand, cloud zone can be seen as slicing your computing resources, right, from that cloud environment, from that public cloud environment. In this case, I have few definitions of cloud zones, and essentially what you get here, it's a policy to tell vRealize how those resources need to be accessed when assigned to the project. So in this case, I'm going to allocate compute resources out of this public cloud environment, and I can do it in many different ways. I can do it very dynamically by just indicating what kind of capabilities these compute resources need to be included in this cloud zone, or I can easily go and just select manually whatever resources are available to me, right, from these regions, and expose it inside the cloud zone. Something very similar happened with the network resources. You can define which networks are going to be available to vRealize and ultimately to the projects that your users are going to be having. And not only that, you are going to define the policies on how the networks are going to be handled. Whenever there is an existing network, you can associate properties to it that the projects are going to leverage whenever they are deploying new workloads, or you can define the policies on how networks are going to be created when building something on demand, right? From which networks are going to be, if you're building something on demand and it has to be NATed or routed, then you can tell VRA how that needs to be handled. I can select which are my external networks, which are my local networks, what is the behavior that I need to do, what is going to be my subnet size for the internal network and things like that. And you can do it for as many types of network configuration that you may want to have inside for your public cloud. And again, something very similar happens to the storage. You define how the storage is going to be handled, right? So you don't really need to tell every time that you build a workload through a cloud template, which data store to use, which IOPs to use. What you actually do, you define those settings as a policy and as an associated capability tag that later on is going to be matched in the provisioning engine based on what the cloud template is requesting, right? And be able to accommodate the request. So it simplifies the whole process of building these resources in public cloud and make it pretty much transparent for your end users. So once you have this configuration done, you can start associating those resources, those profiles into your project. And you can see here, it's as simple as just adding a new cloud zone inside the project. In this specific project, I have multiple cloud resources, private, public, already assigned in this project, including the new public cloud. And you can even filter any further. You can define, you can set limits as well. Again, it's about define your governance around these resources. And in here, you can see that I'm actually allowing the access to that cloud zone, to those compute resources, but I'm even limiting further by saying you only can deploy 20 instances in this project, no more, right? And you can limit it in terms of memory, CPU, or storage as well. You can also define all the properties that need to be enforced, the name convention, anything that as part of your process needs to happen in your project, right? Any constraints to drive the resources to the right profile. Once you have done this, the second part is to enhance the existing cloud templates that you have. As you remember, the service catalog that I show you is actually backed by a cloud template. So this is the one that we are looking at it. And as you can see, it's just one environment at the moment that is exposed. So in order to change this, it's very straightforward. All I need to do is to change the input options, make it simple. In fact, I want to change that name from VCF to something more specific. So I can just add a few lines of code that in turn is going to allow me to create this pull down menu that is going to allow the end user to select the environment. And you can be more granular. Here, I'm just going to super generic, but you can be as granular as needed. You can define specific regions or any other way to access to the specific resources. This is just the input I want the end user to provide, because once I have that information, I can match it into multiple, I can manipulate the data in many different ways and actually create this capability tags that I can be later on match against profiles. I also want to add one more input. In this case, I'm going to use the cost center. And this is important because later on when we have or workloads deploy, I want CloudHealth be able to discover these workloads and apply policies of their own around those workloads. So I want to make sure that all the metadata is actually enforced. And one of the metadata I want to collect is the cost center. And I want the end user to provide that information. So I'm going to add this new input here. Because later on, I can add these metadata tags essentially that can be enforced every time anyone deploys this kind of workload. And you can see, if you look closely, that some of the metadata, the values are actually pulled from the environment itself. When I deploy this, I'm going to be able to collect who's the owner, what is the name of the project. This is metadata that I want to have as part of the deployment all the time. It's going to be enforced all the time. The cost center that we just added, that input is going to be used as the value for one of the tags that I'm going to have. And I can actually fix some some of them very specific, right? So I got multiple ways to collect this information, but the important part here is that it's going to be enforced all the time. So my process of discovering word loops in CloudHealth is going to be very straightforward and transparent to my end users. And I'm going to do it for all the users, all the word loops, all the resources that I have defining here. And not only that, since I'm initializing the application with Cloudini, I'm also going to enhance it by adding log collation. And I'm going to add instructions to install the appropriate client for the log collation. If I'm going to be deploying on-prem, I'm going to install directly the login side client. If I'm going to have the word log deploy in public cloud, then I'm going to be able to actually use the CloudWatch agent in AWS and aggregate all my logs and then send it back to login side. So my operations team can have all the logs regardless on which environment, which cloud environment these word logs are created at. And with that, I can create a new version that I can expose directly in my catalog. So I'm going to add this new version 4. I'm going to give it some name. We're going to create it. At any point, since this is code, you have inside VRA in the design canvas the ability to review this code. What are the changes between versions? If you are familiar with version control management, you can immediately recognize these capabilities. And of course, right now I'm doing it right here in VRA, but you can very well put this code in Git-based version control servers like GitLab, GitHub, Bitbucket, and pull those cloud templates from there and collaborate with your team as well in a different environment. But if you don't want to do that, you can also do it from within VRA. You can have this version control and have this team collaboration to build or enhance your existing cloud templates. With that, I can just go to my service catalog, the service broker in VRA, to make it aware that there is new content available. And with that, my end user, once it comes back to the catalog offerings, is going to find once again this offering available, but this time is going to have a couple of versions, including the latest ones that I have. You can see now that it's going to have the new input that we included and an enhanced way to select the environment for the deployment. So at this point, it doesn't matter if it's private cloud or public cloud. My end user, the only thing they need to do is to provide their intention, their input, and VRA is going to take that input and work with the provision engine, discover the right network profiles, cloud zones, storage profiles, and configure and deploy these word logs for me. So once I submit this catalog item, it's going to create a deployment like this one. And this is my end user's view, right? It's going to have access to all these details. You can actually see now, once we instance that catalog item, which essentially is the cloud template that we just created, that we modify, you will see that it's going to give me very similar visual representation of the word log, but this time it's actually servers that were created in public cloud. You can see right here, I got the detail available. I got all this metadata that was created and that is needed for CloudHealth, right? That is enforced all the time. And pretty much I have details available for every single resource. But not only that, since this is in public cloud, I get access to second-day operations that I can apply. And again, it doesn't matter if it's private or public cloud. I get access to these resources and second-day operations per resource, or even at the deployment level. And more importantly, since this is infrastructure as code, at any point, I can come back to this deployment and say, I changed my mind. I want to update this deployment. We want to move this word log from the public cloud to a different cost center, but also to the private cloud, right? We change our mind for whatever reason. We're doing different kind of testing. Maybe we want to test on all the environments. We don't want to create a new deployment. We can just update the existing one. And what is going to happen is that VRA is going to be smart enough to tell, okay, this is what I have already deployed for you. You change your intention. Let me propose a new plan. And you can see right here that it's telling me, yes, if you want to proceed, I can update the network. I need to recreate some resources, remove some, add new ones, but it's doable, right? And every time that I do any kind of operation like this, a second-day operation or an update, my deployment is going to collect all those details here. Right now, I have the original execution, for the crate, but every time that I update a tag or I do this kind of big changes, I'm going to have those details so I can collaborate with my team and at any given time be able to know what happens with these workloads and what kind of input has been provided. And more importantly, since we are having this public cloud with CloudHealth, and you will see more details later on, you can see that I'm going to be able, as an end user, be able to access the price analysis as I go, and I can do it on a weekly basis, daily basis, and be more conscious of how I manage these workloads for my team. Right, at some point, maybe over the weekend, I can decide to power off all these workloads, so my costs are gonna decrease. Right, so now I got the ability. I don't really need to open any ticket. I can do it by myself. I got access to all this information directly right here on the deployment and on demand. But let's not stop there, right? You are now in public cloud, right? You had your workloads now be able to deploy in the public cloud and in the private cloud. But you can now take advantage of those public cloud resources. In this case, we're using Amazon. Amazon provides multiple management services. Among them, the AWS RDS, which essentially gives me access to database as a service. And if you notice, my existing workload is using a VM for MySQL to enable MySQL as my database. But I want to use this managed service, so I can actually take advantage of these public services and enhance my cloud template very similar to what we just have done, just by replacing that VM resource for a more specific resource. In this case, it will be RDS cluster and the RDS cluster instance, right? If you can see, this resource is nothing but another resource inside the VRA design canvas on which I just need to provide or populate the properties that it needs in order to deploy successfully. You can see here that the system, the canvas is smart enough to tell me all the properties that I have access to it, and I can leverage to configure these databases, right? In this case, I can just cut and paste my properties that I have already available. So you can see that all the properties, such as the instant class, the specific identifier for my precis, how many of them I want to start with, is this public, what kind of engine for the database I want to use. I want to use 5.7. That's exactly what I was having in this VM that I want to replace. So now I'm in the option to actually get rid of this database, so I don't have to worry about the management of the database. Now I will have AWS be able to do it for me. And you can see VRealize is smart enough to tell me, hey, you are referencing in your Cloud Ini information to an existing infrastructure that now is missing. So I need to replace that because now I'm going to have a different database provider, and I can do it. So this is super cool because it's not just what happens on the infrastructure level. I can actually reuse information from the infrastructure and pass it inside the application initialization. Right here, I'm using Cloud Ini, but it could very well use SaltStack, VRealize SaltStack to initialize the application and collect the information of these new resources. And I'm going to do one more thing. I want to make sure that by just dragging and drop this line here, what I'm doing is creating a dependency. I want to make sure that my database, it gets created in Amazon before I can actually deploy my front end. And with this, I'm kind of shifting the management of database to AWS. So all the patching, all the scales, all the backups, they are going to be performed by AWS, so I can focus now on my front-end application, right? And just like before, this is a new cloud template, a new infrastructure as code definition. So I can version this once again. I can release it once again to the public cloud. And with that, I just do the same kind of operations we did before. I just make sure that my service catalog now is aware about this new version. And as an end user, I'm going to be able to come back here, make a request, be able to access the new version. But what is really cool is that, as you can see right here, that I'm just collecting input for my database. My end user, my developer, doesn't really need to worry if this database is going to be landing in public cloud as a managed service. They are just going to get the right work for them. They just need to give me their input, I can submit, and just as before, even though this is a different kind of public resource, it's going to behave like any other resource. So at the deployment level, I'm going to have, again, access to a specific information about that resource. You can see right here, I'm going to get detailed information about that resource, all the state information, all the properties, like who's the cluster members, all the metadata that I also need to enforce. Again, I want to make sure CloudHealth is able to catch the resources. So all the metadata I see also included as part of my code, and I'm able to provide every single information to my end user. And in my front end, right here, I'm building it just as before. I can just go now to my browser and be able to validate that this application is live, having the enhanced backend for my database. So if I need to scale, this database is going to be very easy for me. I don't really need to worry because, again, it's going to be handled by AWS, and my end user, my developer, doesn't really need to worry. And that's how easy it is for you to go from private cloud to public cloud, and even pushing it to take advantage of managed services in the public cloud. And with that, I'm gonna pass control, I believe this time to, let me stop sharing. I believe, Jivan, I believe is you. Yep.
Yep.
All right, awesome.
Yeah, thanks, Francisco. Let me share my screen. All right. So for the cost optimization and security, we will focus on two primary personas, the cloud architect and the senior security manager. The cloud architect would focus on cost optimization, setting the guardrails via policies, and security manager would focus on in-depth cloud posture management. First, let's look at CloudHealth. What you're looking at is the AWS CloudHealth dashboard, which shows you the current month cost, last month cost, and also the projected cost for the month. It also shows the history of cost, the trend over the past 13 months. Now, as a cloud architect, let's look at the assets that were deployed by vRealize automation from the previous step. We will look at the asset report from AWS here. Right, let's go to AWS. Yeah, and let's go to instances. And if we can click on Weave, we will get into the detail of this specific instance. As you can see here, a front-end instance. And let's move on to the tags. Yeah, so this instance has the same tags as the one set by the vRealize automation. So you can also see the VRA blueprint ID over here, deployment ID, and as well as the cloud zone. So all of this data, which is actually coming from vRealize automation, is then used by the CloudHealth to build cost, performance, and security, and other out-of-the-box reports. Let's look at one of the key reports, which is cost history report. Yeah. So cost history report provides visibility into the last 13 months of cloud spend, and as well as the trend. This report displays the cost based on service items. In the category, you can see service items. You will be able to do a slice and dice based on various parameters. You can track the spending by departments, cost centers, individuals, or applications for chargeback, showback, and executive reporting. So as a cloud architect, we can use the integration between CloudHealth and VRA to view costs very specific to VRA deployments now. Let's look at VRA deployments. So as you can see, all these deployments are from VRA, and what you're looking at is the cost elements for the assets which are coming from vRealize automation. Let's click on a specific deployment, which is MOAD AWS, and you will be able to analyze the cost trend very specific to this application. And this report can easily be exported into various formats like PNG, CSV, and can be shared with others. CloudHealth has many other reports that can assist various other personas as well, like performance, governance, and metrics. Let's look at another set of reports that CloudHealth offers, which is Pulse reports. Let me go to Pulse and Health Check. So Health Check report is a high-level assessment of cloud infrastructure's health across cost, configuration, and security parameters. So the first thing you will notice here is on the top of this page is that the possible optimizations for the current month, which in this case is about $4,000. And to the left, you will see immediate monthly savings. So these savings can be achieved by deleting, removing unused resources such as IP addresses, unattached disks, virtual network gateways, and others. To the right, you will notice cloud governance optimizations. These include virtual machine, disks, and other assets that have untagged and unallocated. Since we used VRA templates that had instances and resources pre-tagged, you actually don't see any untagged instances. That's why we see here on the top, no untagged EC2 instances were found. If we scroll down to the left, you will see operational monthly savings. So these are virtual machines and EBS volumes that CloudHealth has analyzed based on the performance data and has determined that these workload could run on smaller instance types, right, while maintaining the same performance. On the right side, you will see security optimizations. These are security risks identified within CloudHealth platform based on best practices provided by cloud providers, as well as industry standard frameworks like CIS, right? So it can also make recommendations on these violations. So let's go a little deep into the operational monthly savings we have, which says 113 severely underutilized EC2 instances, right? So let's look into the details of it, which leads us to the EC2 right sizing report. So in the first instance, what you see here is CPU score of about 1 and network outscore of 0. This actually indicates that instance is running, but is not being actively used. So hence the recommendation, as you would see here, is to terminate this instance. Whereas if you hover over the second instance, which shows CPU score of 12, we can click on the instance and get into the details. So this detailed chart shows about max CPU usage to be about 30%, and then average is close to 10%. So based on this, if we could look at the recommendation for the second instance, it shows that a recommendation is to move from X large to large, thereby saving about $60. So you can also take actions here, right, on these EC2 instances, right? A custom Lambda function kind of allows you to run your logic, right? Like you can create a ticket in ServiceNow and so on. All right, now let's take a look at savings plans, right? So savings plans in AWS offers a very flexible pricing model that provides savings of up to about 72% on your compute usage. There are various commitment options which are available. So CloudHealth curates all of these options for you, right? So the options here, like 1 year or 3 year, no upfront, partial upfront, and all upfront. Each of these options include summarized details about potential costs and benefits. If you look at 3-year upfront plan here, we can see a lifetime savings of about around 57K, right? So by default, all these recommendations are meant to provide maximized savings, but you can easily customize it, right? Based on your needs. You can just have to change a recommended option and it'll change accordingly. So you can do basically purchase a savings plan from within the platform without even going to AWS. Finally, the cloud architect can also build multi-cloud policies. Let's go to policies under governance. All right. So CloudHealth's dynamic policy engine allows you to build custom policies to automate cost-saving practices by building governance policies that basically monitor your environment for opportunities to reduce wasted spend. So let's start by creating one standard policy over here. So CloudHealth's policy engine is quite powerful. Not only you can write a policy to take action on specific cloud resource, but you can also restrict the policy execution to a specific perspective, as you can see here. Perspectives are a way to group your assets based on various parameters within your business context, right? It could be your cost centers, could be applications, could be people like owners and so on. Let's pick cost center as we created that in VRA, and that's of interest to us. And let's create a policy to send an email when the, let's say, EC2 instance cost goes above $100, right, per month. So each block in policy is kind of associated with an asset. Let's select an EC2 instance and let's add a condition. So within one block, you can add multiple conditions. Since our policy of interest to us is related to cost, because we would like to see want to send an email if when cost exceeds the specific amount, and which is $100. Let's put 100 here and then save. We can also add another block wherein we could select Azure. Let's pick Azure VMs here, right, and add a similar condition. Let's select the cost and then type in 100. It's greater than 100. Save it. All right. So we have 2 blocks now, and within each block, you'll be able to add multiple rules and conditions. And once these setting is done, you'll be able to kind of add actions. You could be sending an email, or you could be start, stop an instance, or even write a custom Lambda function. We can also restrict the policy blocks to run a specific for a specific cost center, right? Since we selected cost center as through VRA, and within that cost center perspective, we can select a specific group, let's say, which is engineering. And then all these policy evaluations and even execution would be pretty much restricted to this particular perspective group. All right. With that, let's jump on to the interest of a second persona, who is our security manager. And let's just switch to secure state. So CloudHealth Secure State helps teams mitigate security and compliance risks through intelligent near real-time security, right? So this dashboard here provides a high-level overview of risks and findings. CloudHealth Secure State has about more than 700 rules, which are out of the box, right? Let's look at the findings. So Security Manager can look at all the findings across AWS, Azure, and GCP. To further look at the details of these findings, we can click on the specific instance ID, which is highlighted here. All right. So this is where CloudHealth Secure State is kind of unique, right? So it can show you the context and how resources are related to each other. So the risk score, what we can see here is about 91, since it has a port 22 open to public. And on the right-hand side of the screen, you can see all the resources and the details, and also the tags set by the vRealize automation. If we switch to activity log on the right, since Secure State integrates with the CloudTrail for AWS and also for Insights for Azure, this tool will grab the relevant info about an event and attach it to the object. Let's look at Explore option here. To further understand and identify misconfiguration patterns, right? We can use this Explore over here. Explore is a feature within Secure State that lets you query the data. As you can see here, you can write a query on the top, and the query, you can query the data that Secure State has collected from all the public clouds. You can use this tool not only to find object and configurations that are of interest to you and to your team, but also you can turn these queries into rules, right? So here, since we have put the condition as which has a tag Moid, we can see all the instances over here which has Moid tag. You can basically advance this query to suit your needs. In this case, we are now looking at security groups attached to all of these instances. Let's select this. Yep. So now graph shows relationship between security groups and instances. If we focus on a specific instance, which was highlighted, right, and then we say add to graph, you will now notice the other resources that are connected to this specific instance is also appear here. So with the query we have on the top, we could create a rule with this query. If you see the options on the right-hand side. Once this is set up, Secure State will monitor the rule for any violations in near real time. And also, finally, the Actions tab, which shows various other capabilities of the platform, like you can have alerts, suppressions, and even the auto remediation. Yeah, that's about the cost optimization and security. How is it closely knit with the vRealize automation? And I'll stop here for the Martin to take it forward. Yeah.
Thank you, Jivan. All right, so now we've touched upon how do we use or how do we enable self-service for public clouds, and then also how do we make sure that the cost and security keep under control and make sure that we are not spending too much. I'm going to move this part to my other. And now we're going to dive into managing the applications that are running within the public cloud. So I'll be taking the role of the network architect, and then Tim will come in later to talk about the platform, the infrastructure beneath the cloud that we're monitoring, and also the applications, and then how do we collect logs and how do we troubleshoot these environments. That's the third phase over here. And I'm going to start with a quick introduction into vRealize Network Insight, where we can basically look at the current state of the network and the all of the network, the metrics and all of the inventory and all of the real-time traffic flows that flow through the entire network. So VRNI is not just for public cloud; it also extends that out to your on-premises data centers. Maybe your hybrid clouds with VMware Cloud and AWS, or even your SD-WAN if you're using VMware SD-WAN to connect to your branches or your end users. So all of that information is collated into one pane that we can use over here. And I'm going to focus on the applications because that's where most of the focus is on when it comes to performance and making sure that applications are happy so that end users are happy for that. So if I go to these applications, basically what I want to show you is that we have these constructs that basically make up the workloads that are serving up an application. So if you do have an application running in the cloud, it's most likely multiple EC2 instances or multiple services, or maybe you've even got a hybrid application where you have VMs running in a vCenter environment, and then public cloud instances that are serving up the data to your end users, for example. Those application constructs, you can find them in here where we've just got a simple name and then a tiering model. Like the function of the tier could be API or web or database. And then the members can either be VMs, and that could be vSphere VMs or AWS EC2 instances. Could also be bare metal services, so physical IP addresses, or even Kubernetes services, wherever they may run. The most interesting part is like, how do we get to this application list? We can add them manually, but that takes a lot of work and is manual work. So we do want to use the application discovery method within VRNI. This is how you get the applications that are running within your environment into those application constructs. And then those application constructs will show up in the rest of the data that VRNI has. So it'll be attached to a network flow. It'll be attached to the VMs that are running that application. So once you're looking at a specific point that you're troubleshooting, you will know exactly what application is attached to that data point, whether that be a flow or some metric or anything else. We can do that application discovery based on a couple methods. One of them is tag-based discovery where we can use the same tags that you saw that vRealize automation assigns to the workloads that it deploys. So I think we had the application name, AWS application name, and then also the AWS application tier as the tag key names that Francisco was using in his deployment. And then if I hit discover, I can see all of those deployments directly that are inside the AWS clouds that we've deployed. So it'll give you an application name and then the tiering model with the MySQL servers with 2 database servers in there and then 1 front-end server. So I can save this to the system, select all, just save them to VRNI, and then it'll start showing up in the context. But I can also use a way that doesn't require any metadata at all. So we don't need tags, we don't need a naming convention, we don't need anything in place. Just by looking at the network traffic that VRNI monitors, whether that be traffic from on-prem or from directly from the VPCs within AWS, we can look at the traffic patterns. We can make the connections, who is talking to who, so which VM is talking to which VM over what port. And then we can define that application boundary based off of those patterns. So what happens is that we have the same output. We have this MySQL tier, and we have this front-end tier. It's just taking the names out of the VM names themselves, because it tries to come up with something that's in common between these two VMs. These two VMs. And then you can also save them to the system and start using them for troubleshooting. But in this specific demo, I've already done that. We do have that MOAT application already in place. I gotta get the right one. Yeah, in AWS. So if I click this application name, then I'm taken to the application dashboard, where there's all kinds of networking information around this application, such as a makeup of the incoming traffic, outgoing traffic. So egress traffic is also important to keep an eye out. I can dive into the flows that are going through this application. So every single source destination port combination, and then the graphs behind that. But also more interesting, I have an application topology of what is talking to what within this application. So you can see that the web server is talking to the database server. And if I open up any of these tiers, I get more information around this tier itself. So like which VMs are in this tier. And you can see that there are a bunch of context added here, like which security group is being used that is attached to this EC2 instance. Where is it running? What are the tags? So here are those tags again that vRealize automation adds to these deployments. But I can also look at the raw flows. So these look something like this, where you can already see that one of the sort of security assessments or warnings that Secure State just gave us is already being misused, because we are looking at an incoming flow from the internet to this database server over port 22. So SSH is open and it's actively trying to be used from Shanghai, China. And we don't have any personnel in Shanghai, so this is not a good thing. So you would want to go and as soon as possible add this security group and then just add the deny for the SSH. Another thing that's interesting here is whenever you're using an application or putting it into the public cloud and you're making it available over the public internet, there are going to be end users connecting to that application. And vRealize Network Insight can give you the information that you need in order to determine where to place, in which region to place this application. So on a high level, you can look at the countries. So the US has the most usage, but there's also a lot of interest from China. As we can see, maybe those are just all those SSH scanners, but who knows? But basically, you can just look at who is using your application the most. So where is it still in the right place? So if it's in the public cloud, if it's in the US region, maybe it's in a good place. But if the UK if the UK has more information, more usage, maybe move it to London. One final thing that I want to show you on this dashboard is the microsegmentation planner. And it's called a microsegmentation planner, but it could easily be a security planner, mostly because we can also determine application dependencies here by looking at what is this application talking to other applications. In this case, it's a very singular, solitary application just talking to the internet. But the security planner itself is primarily useful for generating security policies for your VM. So actually microsegmenting these applications, because it knows what types of services are being hosted within this app. And this is an SSH. This is the SSH that's open. And then we have like a web server and all those things. We can also see what types of external services is it accessing, like the raw flows again. So we can have a look at all of the flows that this VM is doing. But more interestingly, we have this recommended file rules over here, which takes the data that we've learned from the network that this VM is using, and then we transform them into firewall rules that you then can apply to either your AWS security group or, well, wherever. If it's an on-prem VM, then you could export and import this into NSX, for example, or your physical firewall, and then you would have the right security policies in place to microsegment. And of course, you can modify this if you do not want to have it like internet facing before you export this list to CSV and then import it into the security solution that you're using. All right, so that's mostly planning, getting more insights into your environment. But now let's say you're troubleshooting a specific problem between two VMs, and then an application owner has come to you like, I want to be able to connect from this web server to this database server, but it's not letting me. Could you look at why that is? For that, we have something called the path search, where we can map out paths between VMs, and that could be an EC2 instance, could be an on-prem VM. And in this case, that developer is asking for a connection towards an on-prem database server from their EC2 instance. And just by typing in path from this EC2 instance to that VM, I get this widget where we can see the entire networking path between these two VMs and all of the networking components in between. So we can see that the virtual private gateway is setting up a VPN tunnel towards NSX on-prem. This is the tier 0, the NSXT tier 0 with a bunch of firewalls in between. So there might be something with the firewall that would be blocking this, because we've got overlapping firewalls, one in AWS and then also one in the on-prem environment. So let's have a closer look what these firewall rules allow. And if I open up any of these objects, I get the relevant information. So this is relevant for this path, and well, we're allowing any outside, so that's fine. Then we can get into the NSXT firewall for the tier 0, also allow any, also fine. The tier 1 is also allow any. And then the VM, the distributed firewall. And here we actually see that we do have a drop rule in place, and it's not allowing anything besides HTTP, SSH, and ICMP. So it's not allowing database connections to here. So I would go in to NSXT and then add another rule in between that would allow traffic from that AWS EC2 instance to that database server over the database ports that developer needs. But the way that I get here is, the only way that I can get here so quickly is by having something like this that overlays both of the environments together. So we can see like the entire network in one view instead of having to go to AWS first, looking at the security groups, and then seeing if that configuration allows it, and looking at the VPN tunnel if that allows the traffic, and then all debugging NSX and all of those things. No, we just have it in one overview. And that's it for the networking part. I'm going to hand over to Tim to show you a little bit about managing these apps on a public cloud using vRealize operations.
All right, thanks, Martijn. Hopefully we're sharing the right screen here. So jumping into vRealize operations, I've just got up our first of all, our AWS cost overview. This is coming in from CloudHealth, our CloudHealth adapter. And really what we're looking for here is kind of our costing trends. So we're getting all of our costs again through CloudHealth for all of our public clouds. And so now we can see that in vRealize operations here. We can start looking through at our total cost overall, month by month, kind of looking at these peaks here to making sure that they're either remaining constant or if they're slightly going up month over month. We can look at our total trend of EC2 instances as well. Looks like we've been trending upwards on those as well. I know we can separate this out. We don't have to look at just our total costs coming in from AWS. We can separate that out by account first of all, so we can look and see what our month-to-date costs are. We can see what accounts are possibly costing us more per month or on a monthly basis than others. And again, we can look at those peaks at the top at the end of the month to make sure we're kind of remaining constant. We can look by region, so we can find out what regions we might have the most EC2 instances in. We can find out what is costing us the most per month region, and then as well as services at the very bottom here. So we can find out if it's our storage, our EBS volumes, or if it's our EC2 instances that are costing us the most, and really kind of get a handle on those costs. So anyone with their vRealize operations can look at some of those costs that are coming in from CloudHealth. But if we want to go with look at the application that we've been talking about today that Francisco has deployed, and we've been looking at from CloudHealth and also from Network Insight side, we can go and find that since we've already got it. It's been discovered using that flow-based application discovery from vRealize Network Insight. So we can go and look at this specific application here. So now we've got the application. We've got the parts that go along with that, our tiers. We've got our EC2 instances, our network interfaces, EBS volumes. That's just kind of what is directly connected to it there. Let's open up and look at our EC2 instances here. Here's that front end server we were looking at before. If I click on this one specifically, it's going to bring up here. It looks like this one is actually has this little red exclamation point letting us know there's some sort of alert going on or some sort of a challenge going on with a particular EC2 instance. But just from our summary page, we can see how much RAM is allocated. We can see how much vCPUs we've got allocated here, what our runtime is. We're looking at CPU utilization, our disk IOPS, as well as our network usage. If we wanted to check and see what that particular alert is, let's go ahead and look at that and see what we've got. Looks like it is running out of disk space at the moment. This particular alert, I believe, fires between 95 and 100% of our disk usage, or disk space, I should say. So that's something we definitely want to take a look at further. And we can do so if we come over to that metrics tab. We can see all the things that are connected. Again, we can see our EBS volume there, our network interface here. We already knew that since Network Insight has discovered this for us, we already knew this part of a Network Insight tier, and there's that tier below it that is the part of the web tier for this particular application. We already kind of knew as the application since that's the way we started our search. And if we wanted to look further at that disk usage, of course, we could go and check that out there. So we can also use then, once we've got Network Insight has discovered our applications and all of the pieces that are connected here, we could go ahead and use our troubleshooting workbench again as well. Now in this case, we've got a pretty low scope, or a narrow scope. We're just looking at this EC2 instance and everything that is kind of one hop up and one hop down from it. So we've got again the tiers and our storage and our network connected there. And if we wanted to change our scope out to see if there's any more events or any sort of property changes or anomalous metrics going on here, that's certainly something we could do, either expanding our scope or changing our time range to see if there's anything going on there for that. We can also, if we want to go ahead and create some dashboards similar to one I've created here, which looks at our application, so our retail shopping cart application here, that will go through and bring us all the tiers and the parts connected for this application, or what keeps this application running. So we can see just our focus at the moment is on the application as a whole, and it's letting us know application health is degraded, which means because of the tier health being degraded, which is that same EC2 we were looking at before, letting us know we're almost at a disk base there for that particular this particular EC2 instance. Or we could then use our heat map here as well, which lists off the tiers, our load gen, our DB, and our web tiers. We could use that use the heat map. We click on that heat map. Again, we get our web tier, which has that same EC2 on it. And we could also go down and see for the web tier in general, if we had more EC2 or more EC2 instances connected here, we could then look at our total alert counts. We can look at our efficiency, our health, our risk score, and our total anomalies. I've also got some down here, some pings out there checking on latencies for our domain names. We can get our peak latency, our peak packet loss, as well as our total kind of query time that's out there to moed.io as well. Now, if we wanted to, again, look into vRealize log insight and kind of see if we're getting, once we have it connected, see if we're getting our logs directly here, I'm going to type in, just go to AWS, and then we're going to look at our log query here. And this is going to show us everything that contains AWS with it. So we're looking at all of our public cloud logs here. We could kind of filter these down if we wanted and look by region or event type or the event name or event source. So we can really kind of narrow things down if there's a particular challenge we're trying to solve or a certain time range we wanted to look into some logs coming in from our public clouds there. We could also create dashboards here in Log Insight. So we've got some AWS logs dashboard here. And this is going to bring in our API calls, our S3 events. Actually, I'm going to change time frame real quick. So now we can see by user, so we can see what our volume by user, S3 events. We could change by region, by user identity type, or by the overall event source. So let's go ahead and look at that one. So when we pull up an event source, now we've got things coming in from S3, so our S3 buckets that are out there. We could look in things from RDS, so our databases, EC2. We can look at STS or KMS, or there's 12 pages of different things we could look at, or not pages, but it looks like it's about 5 or so per page we could kind of search through. So that's really, the way we can get through vRealize Operations and vRealize Log Insight. So let's go ahead and take a look then back at our slides here. So now we've kind of gone through and answered those questions we talked about at the very beginning here. We've looked at our self-service options, our day 2 self-service options. Francisco went over that for us. Javon has gone over and looked at how we can manage our public costs or our public costed usage and capacity, and how we can make sure that those workloads are secure and compliant. And then between Martin and myself, we've made sure we can manage those applications. We can monitor and troubleshoot those deployments should anything come up. And we've looked a little bit about how we can get those logs from our public cloud as well. So that is our session for today. We thank you for attending. Here's that QR code. You can go and get some swag here. So thanks for joining again. I hope you have a great rest of your day and a great rest of VMworld.